This video is a quick introduction to the hyperbolic trig functions sinh of x and cosh of x. Now at the beginning of a Calculus 1 course, most students have never seen these functions before, but they're simply defined in terms of the elementary exponential functions e to the x and e to the negative x. So sinh x is defined as 1/2 times the quantity e to the x minus e to the negative x, while cosh x is defined as 1/2 times the quantity e to the x plus e to the negative x. Now the first thing we want to do here is investigate the parity of these functions. In other words, we want to find out if they're even or odd or neither. So what we do algebraically is just replace x with negative x. So I'm going to say sinh of negative x. And then what we look for is whether or not the original function pops out after we make this substitution, or the negative of the original function, or neither one of those things. So making the substitution on the sinh function, I get 1/2 e to the negative x. Again, we're just replacing x with negative x, minus e to the positive x. And then I realize that I can reverse the direction of this difference by factoring out a -1. So I get -1/2 times e to the x minus e to the negative x. And so what I ended up with is the negative of the original sinh function. And that means this function is odd. So when we make a graph of this function, we should expect to see odd symmetry. In other words, a 180-degree rotational symmetry about the origin. As for the cosh function, when we substitute negative x for x, I get the cosh of negative x. That's 1/2 e to the negative x plus e to the positive x. And of course, these two things are the same. I can just reverse the direction of that sum, and I've rediscovered the original function, the cosh of x. So if replacing x with negative x results in the original function popping out, that's an even function. That means that when we graph the hyperbolic cosine function, we should see even symmetry, which means it has a reflection symmetry about the y-axis. So the final thing we're going to do in this introduction is sketch the graphs of these two hyperbolic trig functions. So we're going to start our plot of the hyperbolic sine function by looking at what happens if x is 0. So we want to compute the sinh of 0. And when I sub in x equals 0, this e to the x becomes 1. But the e to the negative x, that's also e to the 0, which is 1. So in these parentheses, I have 1 minus 1, and that's 0. So the sinh function passes through the point 0, 0, in other words, the origin. The next thing we're going to do is investigate the long-run behavior as we go right and left of the origin, and this will give us what we need to sketch the graph of the function. If I think about x moving to the right of the origin, this first term, e to the x, starts to become very large and positive really quickly. This is an exponential function. It's going to grow rapidly as x moves to the right of the origin. On the other hand, the second term, e to the negative x, becomes small really quickly. That's 1 over e to the x, but e to the x becomes large. 1 divided by a large thing means we get a very small contribution from that term. So it's a good approximation to say the sinh of x approaches the function 1/2 e to the x as x goes to the right of the origin. In other words, we're thinking of that function 1/2 e to the x as kind of a curved asymptote for the hyperbolic sine function. So this dashed curve is the graph of 1/2 e to the x, and the hyperbolic sine function should approach that pretty quickly as x moves to the right of the origin, and that's exactly what we see when we put in the right half of the hyperbolic sine function. Now we just do the same thing for the left half. If x is negative, then this e to the x term is shrinking rapidly as we move to the left of the origin. We're getting bigger and bigger negative exponents. Now it's the second term that dominates this difference. If I plug in negative values of x, that means positive exponents for this term, negative e to the negative x. And so the sinh function is well approximated by just ignoring this first term, and I get -1/2 e to the negative x for my curved asymptote. So there's a picture of that. And again, we're going to see the sinh function rapidly approaching this curved asymptote as x moves left of the origin. So there's our standard graph of the hyperbolic sine function. Now I want to point out that we see in this graph the odd symmetry of the hyperbolic sine function. That's a rotational symmetry of 180 degrees about the origin. So it's behaving like we expected it to. Finally, we're going to produce the graph of the hyperbolic cosine function. And we're going to start out the same way. I want to evaluate cosh of 0. When I sub in 0 for x in these two terms, they each become 1. 1 plus 1 is 2, and half of that is just 1. So the cosh of 0 is 1. Now we look at our long-run behavior to the right and left. And again, as I move to the right of the origin, this e to the negative x term becomes negligible rapidly. And I should see the cosh function approaching the function 1/2 e to the x. So there's kind of our curved asymptote for the hyperbolic cosine function as we move to the positive values of x. And we see the actual graph of the hyperbolic cosine function approaching that curve pretty quickly as we move to the right. Again, as we move to the left, it's the e to the x term that becomes negligible as we start subbing in larger and larger negative values of x. And the hyperbolic cosine is then well approximated by 1/2 e to the negative x. So there's our curved asymptote to the left of the origin. And when we plot the hyperbolic cosine over there, we see it rapidly approaching that exponential asymptote. Finally, recall that we proved algebraically that the hyperbolic cosine function is an even function, and we see the appropriate symmetry as a result. This has a reflection symmetry about the y-axis. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left, or click the Zach's Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.